a steam turbine with 85% stage efficiency. Let's say that is our turbine efficiency. Receives steam at 7 MPa and 550 C. That's our first state. And exhausts at 20 kPa. Determine the turbine work. It sounds like we are trying to find our actual turbine work since we are given our stage efficiency. So this is in kilojoules per kilogram. So in order to find our actual turbine work, we need to multiply our ideal turbine work by our stage efficiency. So we already have our stage efficiency right here. So we just need to find WT. WT can be found by taking H1 and subtracting H2 from it. So we're already given our H sub 1. We just need to find our H sub 2, which is not given. We do need to find H2 first, using this formula. Alright, so HF we are given over here. X is not given. HFG2 is over here. So we still need to find our X, or steam quality, by using our entropies. So S1 is equal to S2 because it's an isentropic process, and that is given by SF2 plus X SFG2. So we're given our S1. S1 is equal to S2. SF we're also given, and SFG we're also given. So now we can find X using shift solve. So this one is 6.9486. SF is 0.832. Trying to find X, and SFG is 7.0766. And simply put that in our calculator. We get a steam quality of 0.8643. Okay, so now we have X here. And let's put our values in. HF2 is 251.4 plus the X we just found, multiplied by HFG, 2358.3. So that should give us 251.4 plus 0.8643 times 2358.3. We do get an H2 of 2289.68 kilojoules per kilogram. Okay, so now we have H2 as well. We are able to find our ideal turbine work. So H1 is 3530.9 minus this 2289.68. Let's do simple subtraction in the calc. That is 1241.22 kilojoules per kilogram. Now we finally have our ideal work, so we can find our actual work. WT prime. 1240.22 multiplied by our stage efficiency. And let's see what that is equal to. 1055 kilowatts for our actual turbine work. And that is our final answer. I hope this helped. Consider liking, subscribing, and supporting me on Patreon. Thanks and good luck.